Dear students, welcome to the course of AR 310 Architectural Studies for Engineers. I am your teacher Ravinder Kumar Khyani, Assistant Professor, Department of Architecture and Planning, NAD University of Engineering and Technology, Karachi, Sindh, Pakistan. Last time we have begun with the topic Fundamentals of Aesthetics and Relevance to Engineering. This is in continuation with the topic. This is the second lecture of this topic, and this is fourth lecture. Today we will discuss about the application of aesthetics in engineering design process. In last lecture we have discussed the need for aesthetics in engineering and aesthetics as a part of engineering design. Today we will continue the theme of aesthetics and its relevance to engineering. Therefore, at first, let's understand the engineering design process and analyze where aesthetics is applicable to the process. The engineering design process is a series of steps that engineers follow to come up with a solution to a problem. Many times, the solution involves designing a product like a building, infrastructure, or any urban space that meets certain criteria and or accomplishes a certain task. This process is different from the steps of the scientific method, which you may be more familiar with. If your project involves making observations, doing experiments, and constructing a theory, then you should probably follow the scientific method. If your project involves designing, building, and testing something, you should probably follow the engineering design process. Let's make a diagram showing the steps of the engineering design process and then discuss at each step in more detail where the application of aesthetics is possible. The typical engineering design process and aesthetic application. The engineering design process begins with the defining of the problem. That is the first step. Then the second step is doing a background research about the problem. And then again defining the problem. The third step. The third step is specifying requirements of the clients and the users. Fourth step is brainstorming, evaluation, and choosing solution. Fifth step is developing a prototype solution for the problem that you are doing engineering design. The next step is test the solution that you have developed. Finally, the testing of solution leads you to two things. Either solution will meet the requirements or solution does not or partially meet the requirements. In both cases, you have to communicate the result to your client as well as users. Then, in case solution does not or partially meet the requirements, based on results and data, make design changes, prototype, test again, and review new data. So you have to do brainstorming, evaluation, and choosing the solution, then developing a prototype solution, again test the solution and find out that whether solution meet the requirements or not. So this is the whole engineering design process. Engineers do not always follow engineering design process steps in order or one after another. It is very common to design something, test it, find a problem, and then go back to earlier step to make a modification or change to your design. This way of working is called iteration, and it is likely that engineering process will do the same. Here the question comes to mind, where do we apply the aesthetics in this engineering design process? To find the answer, let's draw the diagram again and discuss in detail each step of the process. First step was defining the problem. The engineering design process starts with finding an idea by identifying the needs and wants of the client or the people. The act of looking at the world around you to identify these needs is called need finding. For need finding, create a list of all the things that annoy or bother the people. Record this list of problems people face in their built environment. Make mind map of possible design problems, ideas, and areas of interest. Once you found an idea for engineering project, describe the problem by writing a problem statement. Your problem statement must have answer of three questions. First, what is the problem or the need of the people? Who has the problem or the need? Why it is important to solve? Before moving forward with an idea for your engineering project, be sure to evaluate your problem. That who needs what and because why. So in this way, answering these three questions, you can have a problem in front of you. So here is the point from the first step of engineering design process where you think and decide that whether aesthetics is the part of your idea or the problem or not. So aesthetics is applied from the first step. Let's go to the next step. Let's go to the next step. And next step is what? Doing background research. Background research is especially important for engineering design projects because one can learn from the experience of others rather than repeating their mistakes. To make a background research, a roadmap of the engineering question is prepared about the needs, wants, and problems of the target groups, users, or clients. Identify questions to ask about the structures already exist so as to solve the problem you defined. For instance, if there is a building which have no consideration for aesthetics, so then you can identify that this is the problem. So network with other people with more experience such as mentors and explore existing solution and ideas. At this step of engineering design process, an engineer can explore the aesthetics of existing structures. Find out how the other engineers treated their buildings in terms of material, structure, shape, and form. Also, what are the user group or client's choices and preferences about the building structure and the construction style? So, step two is quite significant for aesthetics value judgments and deciding about the aesthetic as a part of engineering design process or not. Third step, specifying requirements. Design requirements state the important characteristics that your design must meet in order to be successful. Once the best ways of identify the design requirements is to use the concrete example of a similar existing project, noting each of its key features. For example, if you are going to design a structure for house, then you look at the earlier houses. If you are doing it for the apartment, then look at other apartments. Similarly, whatever building type, whatever structure you are going to design or your requirement is, you just look at the earlier examples. To create a list of design requirements, ask the right question from the problem statement you made during the background research. For each problem, ask yourself what is absolutely essential to solve this problem. What are the physical, social, economic, and structural requirements of the project as per its users and clients? Because user and client is very important and their needs should be fulfilled. The answers to these questions make specific design requirements for an engineering project. At this step also, one can ask the question about the aesthetics of the project as per user group or client's choice or preferences as physical and structural requirement. Do we need aesthetics or not? Or as a lesson learned from the background research of the earlier structure made by previous or senior engineers, they don't had the aesthetics quality, so you have this quality incorporated in your design. Fourth step of brainstorming, evaluation, and choosing the solution. Brainstorming is the process of finding out possibilities for solving design problems. If you focus on just one solution before looking at the alternatives, it is almost certain that you are overlooking a better solution. Good engineers try to generate as many possible solutions as they can before choosing one that they feel is the best. This creative process of developing ideas is called ideation. Methods of ideation include examining existing solutions, creating and using analogies or comparisons, conducting brainstorming sessions, sketching and doodling. Doodling is like rough sketch, a rough drawing, a rough idea. Professional engineers consider universal design criteria when choosing which possible solution to implement. What is universal design criteria? Universal design criteria is applicable to every situation. For example, the project should have elegance, the project should have robustness, the project should have aesthetics, project should be having less cost, or appropriate resources should be available. Time management should be there, and the skill required for the construction and making the project should be there, and safety at the creative process or execution process of the building should be there. So universal design criteria have all the good qualities that we have explained. So engineering design development involves refinement and improvement of a solution. Methods of design development work and evaluation include drawing, modeling, prototyping, storyboards, and analysis. In next step, developing a prototype solution, a prototype or mock-up is an operating version of the solution made with different materials than the final version. Creating prototypes may involve using readily available materials, construction kits, storyboards, computer models, or other techniques that help to create the design solution quickly and with little cost. Prototype allow to test how design solution will work and even shown the and presented the solution to user and clients for the feedback. At this step again, aesthetics of any engineering design project can be judged and evaluated either by clients or the users. In next step of test solution, the design process involves multiple iterations and redesigns of the final solution. It is likely that a solution is tested and found new problem, made changes, and test new solutions before final design. Test and redesign requires sharing of the final design with users and the clients so as to get their positive feedback and satisfaction. Based on the feedback and interaction with solution, it is redesigned to make it better. This process of testing repeated issues determined fixed, and then retesting multiple times until the solution is finalized. So quite often the users and clients make value judgments and aesthetic judgments on the solutions, and it also lead to redesign and retest of the solution. Thus, in all engineering process, there is a issue of aesthetics that is involved at each step of the design process. To complete the project, results are communicated to others in the form of a report and display board. Professional engineers always thoroughly document their solutions so that they can be manufactured and supported. Thus, aesthetics is not only a relevant aspect of engineering but also applicable to the whole engineering design process. The examples of aesthetic application in engineering practices. In last lecture, it was pointed out that aesthetics has become an engineer's concern. Globally, engineers developed various projects where aesthetics is their prime concern. And it is evident from the fabric structures, the mast and telecommunication tower design, stormwater management in an urban environment, scaling the monuments, and adaptive reuse projects. And these are the few examples that we can quote. Apart from these examples, there may be many other projects or project types in which aesthetics is very much incorporated. In the following, we will see some of the examples of aesthetics application in engineering practices around the globe. First of all, let's begin with the fabric structures. Fabric structures are tensile structures in which a membrane is stretched to form a three-dimensional surface that can be used to create a roof, shading, or decorative component. Look at the examples of the fabric structures. Sometimes described as modern tents, fabric structures use very little material compared to other forms of construction and are typically translucent, but they provide little thermal mass or insulation and can have a shorter lifespan than some other materials. See other examples of the fabric structures where you will find the tent form or a shade form, and you can see how the overall form is. Aesthetically, they are all beautiful forms. Continuing with the fabric structures, typically the membrane is formed by a structural fabric consisting of a woven base cloth coated on both sides and held in position by tension forces imposed by a structural framework or a cabling system. Unlike conventional roofing system, fabric structures can cover very large areas with no supporting columns. This makes them particularly suitable for buildings such as sport facilities, auditoriums, shopping centers, transport interchanges, and so on. In Karachi, you can find many marriage halls are made with the fabric structures. See the example of shades in fabric structure. They can be relatively quick to construct and can be relocatable, making them suitable for temporary uses. See, you can make a tent out of it. The structural stability in fabric structure is achieved by anticlastic and synclastic. Anticlastic and synclastic or saddle shaped or dome shaped form, which makes it aesthetically appealing for the people. Next example is mast and tower design. The term mast and tower are often used interchangeably. You have seen this kind of towers in our city. However, in structural engineering terms, the tower is a self-supporting or cantilevered structure, while the mast is held by stays or guys. See, tower. A mast is a ground-based or rooftop structure that supports antennas at a height where they can satisfactorily send or receive radio waves. Radio masts and towers are typically tall structures designed to support antennas for telecommunications and broadcasting, including television. Typical masts are of steel lattice or tubular steel construction. See the example. Masts tend to be cheaper to build but require an extended area surrounding them to accommodate the supporting guy wires. The next project type where aesthetics is very significant issue is stormwater management in an urban environment. In this regard, we have to see the example of Singapore. In every city, there is a rainwater drain, almost in every city. So in Singapore also there is a rainwater drain within the city. Similarly, in our city Karachi, we also have rainwater drains, two rainwater drains known as Liari River and the Malay River. Now, in Singapore, they are trying or transforming their drainage system into re-neutralized streams and bioswales that enhance the urban living. It means that they are biologically improving their stormwater management system and they are putting more vegetation and using or recycling the water. They are enhancing the livability through new approach to stormwater management in their city. And these are the pictures that you can see. This is taken from this source. This time I haven't made a list of references of images, but put the references over the images. See, this is Liari River, and if you can see on the picture on right bottom, the Liari River passed through whole city. It is 17-kilometer long river passing through the center of the city. And this is the thing that we have put the effluents of the industry in the Liari River. And this is the picture from a site area on your left. So, Liari Nadi Karachi needed plan for stormwater management. And Liari Nadi Karachi need an aesthetics approach to stormwater management, just like we see in Singapore. In Singapore, the water bodies design panel redesigned concrete stormwater collection ponds into natural looking lakes. Singapore aspires to become a city of gardens and water. This is their policy. So, if you make a city of gardens and water, definitely aesthetically it will be of high quality. And this quality they wanted to achieve. So, aesthetics is their main criteria. On the other hand, if you look at our local context, you find that on Lyari Dadi Karachi, we are making expressways on both sides because our focus is not aesthetics but functional requirements of the city. And Lyari Nadi Expressway is developed or Lyari River Expressway is developed to solve the traffic problems because we are more focused on traffic problems. So in every context, it is not necessarily that aesthetics is applicable, but even in this case, if you look at the Lyari River, you find that aesthetically it is more better than the previous one. However, it is not as green as of Singapore. But I hope soon our cities will also look beautiful as other cities in the world. The next theme is scaling the monuments. The major application of aesthetics, if you wanted to see across the globe, you find that it is in the monuments engineering. When people are engineering monuments projects, then what is the aesthetics that they used to apply? Let's see. Construction engineers gave us so many large scale monuments, having aesthetic effects on the societies in which they exist. In the following, we will see the world's largest monuments having monumentality and scale of grandeur and have a high quality of aesthetics. Look at this 597 feet or 182 meters high Statue of Unity. You see, it's a bridge crossing the river and the scale of the monument, how big it is. It's the world's largest monument. This is again another monument. It's 420 feet or 128-meter high Spring Temple. You can see the huge staircase going up, and the people. If you consider a person who's walking on the staircase leading towards the monument, see how gigantic the monument is, how big a scale it has. This is 380 feet or 115.8 meters Lekyu Sekhya monument. This is 330 feet or 100-meter Yushiku statue. See how big the scale is. So this kind of design is not only made by the architect or any other designer. It requires engineering skills to execute such a big, huge project. So there is lot of engineering involved, and you can see that engineers are producing so many aesthetic elements in our world. Again, sources mentioned of these pictures. This is again a 289 feet tall, 88-meter tall Daikanon of Kitano Miyako Park. This is in Japan. And see how big the statue is. See, sometime one statue can be heavy on the whole landscape of the city. Whole city is basically known from with this that particular monument. This is 330 feet tall, 100-meter tall Sendai Daikonon monument, and people can see this monument from miles away. This is again 302 feet or 92 meters high Wat Muang temple. See the landscape. When we are making a monument, we also have a large landscape and we have a good background and foreground. So that monument will be having a grandeur of its own. This is again a monument 325 feet tall, 99-meter tall, Goshan Guanyin. See how big the scale is. This is again a 279 feet or 85-meter tall World War II memorial, and it's very huge scale of monument. This is another 259 feet tall, 79-meter tall statue in Lingshan, and you can see the statue is like 500 meters away, and how big it is. This is again 249 feet tall, 76-meter tall bronze statue of Dizang Pusa. Similarly, 260 feet tall or 80-meter tall Awaji cannon or Hiva cannon. So you see the engineering projects. There is a building, and over the building there is a big, huge monument or a statue which is made. This is again 249 feet tall or 76-meter tall Ghanaian statue. See how big monument this is at the edge of the river. 256 feet or 78-meter tall Ghanaian of Nanshan. It's in China. So there are huge, large-scale monuments and statues. This is 190-foot tall, 58-meter tall Guan Yu statue. See the excellence of engineering that is evident over there. How engineers thought about the aesthetics of the whole city and a dominant element that encompasses or give the aesthetics to whole city. See how big this monument is. 246 feet or 75-meter Garuda Vishnu Kenkana statue. See the building and the scale. If you think of a human, how big it will be? It will be like a dot in the picture. So such a scale of monument is the engineering expertise, or you can say it is an engineer's you can say contribution towards the aesthetics of a city, towards the aesthetics of a monument itself. And large scale projects are also other projects you can see, like this one's 161 feet tall or 49-meter tall statue, monuments of the African Renaissance. This is everybody knows 151 feet or 46 meters tall Statue of Liberty in USA. This is 130 foot or 40-meter Genghis Khan equestrian statue. See the horse at the bottom, and see the horse that is there of the monument. How big in scale it is. This is again 98 feet or 30-meter tall Christ the Redeemer in Rio de Janeiro, Brazil. Finally, we have the project of adaptive reuse. Adaptive reuse is defined as the aesthetic process that adapts buildings for new users while retaining their historic features and characteristics. Using an adaptive reuse model can prolong a building's life from cradle to grave by retaining all or most of the building system, including the structure, the shell, and even the interior materials. This type of revitalization is not restricted to buildings of historic significance and can be a strategy adopted in case of obsolete buildings. Revitalizing the existing built fabric by finding a new use or purpose for obsolete buildings can be a wonderful resource to a community by keeping neighborhoods occupied and vital. Some urban planners see adaptive reuse as an effective way of reducing urban sprawl or urban expansion and environmental impact of the urban expansion. Adaptive reuse is a new kind of maintainable rebirth of a city or the buildings, as it covers the building's lifetime and evades destruction waste encourages recycles of the embodied dynamism, and also delivers substantial social and economic profits to the world. Let's see an example, a case study of adaptive reuse project. I suppose this will also help you in making your own assignment, which I have told you in last live session. So after built structure become disused or abandoned, adaptive reuse can be the perfect way to breathe new life into an old building while conserving resources and the historic value of the area as well as building. There is a chapel on a hill, very old chapel, and there is huge, you can say, vast land available, virgin land available. This abundant structure having no use because earlier it was a chapel and church, but now it has no use. These are the old users of the chapel who used to study here or come for prayers on Sundays. Due to environmental reasons, land availability, or the desire to conserve a historic landmark, countless engineering firms worldwide are turning to adaptive reuse practice as a solution to some of the modern problems of the built environment. Because when people abandon the building and it is not occupied, then some people think that why not we recycle, just like it comes the concept of recycling or reusing. This is concept of adaptive reuse. We reuse the old buildings and give them the new use. So this chapel also got the new use. With this thing in mind, this case study is compiled as adaptive reuse project, which utilizes an old structure to create a revitalized form in its own distinct way. So let's look at the adaptive reuse of an abandoned structure. What would be the possible use for a chapel which has nothing in the surrounding but barren land and green lush land? So what should be the use of this old structure? Once a 19th century chapel, this is holiday cottage now. So this holiday cottage conversion took a building heavily damaged by strong winds and rains and turned into a comfortable vacation residence for 7 guests. See the old building which is abandoned and how it is improved and new building come up. See the old hall and see the new hall. What is the change that comes to this building? This holiday cottage changed from a chapel show the aesthetic vision of an engineer and the architect together, that how wonderful this space become for the guests who come and live in this place as a holiday. These are the views of the building which is conserved and improved and then adaptively reused. This is like front elevation where you see the overall facade. There is a gable roof, large bay windows, and a central access or entry. And these are all the new, the red color gates and the door windows are the new additions. Even the surface treatment is also made in this, you can say, front elevation. And there is new, you can say, pavement, which is also made. And you see, this is now more a close view or zoom in view of the building or the door and windows. You see right side elevation. So there is a mix of old materials with the modern materials. that is evident in this building. This is a ground floor plan where you have entry from the left side and from the right side, from the bottom. From the left side, you see as you enter, as you see in the first front elevation. Front elevation is from the left side of this plan. As you come inside the building, you find there is a lobby, and on the left there is a washroom, on the right there is a bedroom. Then you move ahead, then there is a study area, and there is a piano, and then there is a living room, and further you go ahead, there is a dining, and then there is a kitchen, and then there is a staircase going up from the central area also, and from a corner also. There are two staircases. One is emergency staircase on the right bottom corner, and once the at the study there is a staircase going up to the first floor. Now this is first floor where the staircase is coming from the center, and there is an suite for one person or a couple. There's a bedroom. There's a one single bedroom and two double bedrooms with an suite or a big washroom. Let's see inside what changes have made. This is entrance to the holiday cottage. This is the gate from where you enter, and then this is the kitchen and the eating place which is made in this uh, holiday resort. Then there is dining and discussion place. See how beautiful they have developed this. You can see the interior of the building, which was an old chapel, now is a beautiful living space with modern material application, and it is given a new use, and that is the and giving new elements inside it by keeping the characteristics of an old building as well as giving the new interiors. This is kitchen and dining room at ground floor. This is the staircase going up, and there is a study area near the staircase. This is the family lounge, and there is staircase again you can see. This is wall treatment or color scheme. See how black and white is used, how the neutral colors or natural colors are used. This is cozy lounge and piano place which is there. This is the first floor where the staircase ends. This is single bed or guest room for a single person. This is the ground floor bathtub. This is guest room for a couple. You see how the roof is treated and window is created over there. A glass window is given, and directly it puts the light on the bed. Okay, here is a detail of the gable roof treatment or the window I was talking about. How beautiful it is placed in the roof, and there is a scenery when people are living in this room. They feel they can enjoy the outside environment, and in the night they can also enjoy the stars. This is a toilet. Again, a roof is treated with a window, and furthermore, this is the makeup room within the bathroom at ground floor for the couples. I believe with this lecture, you have clear understanding about the adaptive reuse project, and also you have the understanding, or you have developed the understanding that how to present your work. For example, in your assignment, when you are doing a similar kind of project, documenting your own house, you can use this kind of you can say presentation. Okay, last but not least, again I would like to show the people behind this lecture, the great people, the great writer and authors who have helped me or who have inspired me to make this lecture and present it to you. Thank you very much. Goodbye.